So a while back, when my roommate and I were still in college, he had a final project to create Hangman that he didn't end up doing and still passed the class. He was ending up switching majors, so he didn't really care. I said, I was like, oh man, Hangman is super easy. I could do it in 30 minutes. So I did it in 20. Yeah, I know it's pretty bad. The important part of this is I just so happen to have a download of a whole bunch of words. So if I open this up real quick, you can see that I have all of the words that have A in it. But there's a little bit of a problem. Some of them, I don't need 9 different copies of the letter A. And A with a dash, A with a what? And if you keep scrolling, there's even more absurdity that you keep finding, which of course I'm not finding, but there's like some database errors and just garbage data in general. So I had to clean that up before I could do anything with it. Now, the other thing that's important for context in this story is that my C button on my computer is breaking. If I type C, like I'm doing right now, like I'm pressing it a lot, and it barely works. So, as I was writing stuff for college, I was trying to avoid using every word that had any C in it. And I realized that that's kind of actually a hard thing to think about when you're trying to type. It's just trying to avoid any word with a C. And it gave me an idea for some sort of word game. The idea being that you get a set of letters and you have to try to think of a word that contains those letters. And so I needed to clean the data. So I wrote a little code. To clean up the data. So I just checked to see if my fixed words directory exists so that I can just delete it and it will regenerate everything. And then if I don't have all the words, because each letter in the alphabet is split into its own file, if we don't have our original words, then we just return because nothing's gonna work. And then we proceed to actually fix the list. So we just grab all the files in the words directory, and then we loop through all of them and run this fixed list method. If we come over here, all I'm doing is basically reading each line one at a time from the file. We increment a counter for just statistics later, and then we call this method. If we don't have an invalid character and the fixed words list doesn't already contain that word, then we add the word. And then we just quickly do a little bit of stuff here to just write it to a file. And then the invalid words, probably a better way to do it, but I was lazy, so I just made a string of a whole bunch of invalid characters that I don't want to appear in any of the words, and then I just loop through each character in the invalids list and make sure that our word doesn't contain it, and then we return true or false appropriately. So if we come over here and we delete the fixed words directory so that we can run it again, you can see what the extra little bit of code, we don't need Hangman anymore. If we come over here, start the project, you can see what the extra little bit of code there does. Oh. Well, that was stupid. We'll close that real quick. So if we come over here, we can run it real quick to see what it does, and you can see that it just runs through every single thing, fixing the thing. So I just made it print out this nice little thing as it goes through that's like, oh yep, there were 11,616 words from the A word list, and we removed 3,891 duplicates. And so our final list only has 7,725 words in the A file, and it just does this for every single file. Now this is going to be important for the next stage of my thought process. So, obviously, if I ask, what is a word that contains the letter D, everybody can come up with a word like dog. It's really easy to come up with a word that has the letter D in it. So, the idea is to make it so that instead you pair 2 letters together, like L-I. So, now you could maybe think of list, or you could think of a word like duplicate. So it's a little bit more difficult. It limits the kinds of words you can find, but it's still relatively easy. So my thought is to now go through all of the different words, basically create every combination of 2, maybe 3 character strings in all of the words that are possible, and then go through every single file and see, okay, does this actually appear in a word? If it doesn't, we're going to get rid of it because we don't care. And while we're doing that, we're going to count up the number of times it does appear in common words. That way we can create a list of common to more uncommon pairs of letters in words for people to try to think of a word that it goes with. So, because I can't be bothered to try to figure out what the most common letter combinations are, we're going to write a program to figure that out for us. So the first thing we need to do is generate letter combinations of any size. So because I want this to be variable and expandable, what I'm going to do is write a method to generate every letter combination up to a certain length. So for obviously, if we're just doing a length of 1, it just prints the alphabet. If you do 2, then eventually you get to AA, AB, AC, so on and so forth for every single letter. So let's write a method that we can change how big of a chunk we want to generate so that we can just look at some different things. So basically, the code being magically written before you, basically what it's going to do is for however long of a combination we want to make, it's going to do a loop every single time. Then basically what we want to do is say, hey, if we don't have any combinations yet, just generate the first set. So else what we do, we are going to then read back the list that we just created, and we're going to add another set of A through Z to that, and then add that back to the combinations. We now get every combination up to ZZ. So if we just kind of scroll through, you can see that we get all these different letter combinations. Now obviously, I don't even know if any of these show up in words in English language, which is why the next stage is to actually see how common each one of these are in the entire alphabet. There we go. All right. So this is actually relatively quick, so this is good. So we're running through every single combination and we're looking through all of the different files. Whoa. Oh, the path does not exist. Yeah, that would be something to handle. Doesn't exist. Then I want to do directory dot create directory combo data. Wow, the combination ZZ appears 145 times. I would have never guessed. So now that we have our word data, we should have a file here. And here we go. So as expected, obviously one character letters are going to appear a lot. And then obviously less common are going to be your 2 characters. Okay, so CX does not appear whatsoever at all in the English language. So if you want to make a new word that you don't have to worry about if it's been made already, just have CX in it and you'll be good to go. So the next thing we want to do, wow, we got a lot of the Qs don't have anything. QA appears in one singular word. I wonder what it is. The issue with how we've done things now is it doesn't really lend itself to sorting very well. Let me think about that. Okay, so I was thinking about how to solve this problem, and I instantly went for the best solution. Now, I could have just made it a check in here that, hey, if the list already contains this, don't add it again, but that would waste performance. So what I came up with instead is creating an index to start from. So the first time around, we don't have anything to look at, so we're not going to worry about it. We go through it and add on all of our letters. The second time we want to start at 0 and go all the way to 26 so that we can add it to the second. Now the third time we do this, we don't need to look at the first 26 letters because that would just make a duplicate. So, and I found this process interesting, so I kind of wanted to show it. So we have our different, our different runs. We'll just go to 3 to worry about. So the first time we don't really have to do anything, so we can just ignore it. The second time we want to go from 0 to 26, and then the second time around we don't want to get 26, so we want to go from 26, well, technically 27, from 26, and we want to go to the end. Well, this would be 26 times 26, and then the third one would be from the second one, which would be 26 times 26, to 26 times 26 times 26. Now this pattern is pretty simple. This is just 26 squared, and this then becomes 26 cubed, making it nice and easy to create a function that allows us to know what place we're supposed to start based on what loop we're on. Alright, so now that we have all the data that we need, we can actually start building the little game thing. So I've went ahead and created a couple things here. First off, I've created 2 variables for our floor and ceiling. So the idea is that we don't want anything that has less occurrences than 500 occurrences in our words, because I figured nobody wants to be trying to figure out the one word that contains that combination of letters. And then I put a ceiling on here as well that I kind of loosely based off of looking at the actual data so that we don't get things like E, which is the most common and super easy to complete. So then I created a list of string combos, and we just loop through all of the combo stat items that we have, and then we just look at the count and say, hey, if the count is greater than the floor and less than the ceiling, whoops, which I hard-coded there for some reason, then we're going to add just the actual phrase to this list so it's easy to parse. Then we create a random number here between 0 and the length of our combinations list, between 0 and the length of our combinations to get one single combination that we're going to try to do. We're going to then pick that out of the list, and we're going to print it to the screen. And then we're going to get the user input because they're going to try to figure out a word. So the first thing I do is, if it doesn't contain the combination, we're just going to return false right away. This is because we now have to look through our dictionary to see if the word exists. So I made it into just a basic little game, and this is where I've discovered a major problem. Alright, so it works. So TR, okay, try. So my brain thinks of come, but watch what happens if I do like comes. Comes doesn't work, but come does. Some words just don't work that should be there. And I actually went through and manually looked through some of the dictionaries to try to see if I could find the word. But it just doesn't exist in there. So I'm going to need a bigger word list because I noticed a lot of it will not recognize the plural version of a word. So I need to find a bigger word list, and hopefully in a similar style as the first one that I found so that I can have more words. But that will be a problem that we'll solve in part 2.